Machine learning is growing quickly. If you're into technology, knowing the right algorithms is important. This article discusses 10 essential machine learning algorithms. Beginners and aspiring data scientists should know these. Getting good at these skills will let you make useful models and improve your grasp of data. Types of machine learning algorithms. Supervised learning. Supervised learning happens when a computer looks at examples with the right answers. The goal is to find a pattern so it can make predictions for new data. Some common types include: 1. Linear regression helps predict numbers by finding a pattern in data. 3. Decision trees. These work like a flowchart, making choices step by step based on given rules. 5. Support vector machines, SVM, sort complex data into different groups. 6. Neural networks, a strong system inspired by the human brain. 6. They recognize patterns and solve tough problems. Unsupervised learning. Unsupervised learning is when a computer analyzes data without clear answers. It seeks to find patterns independently. Some common methods include: 1. Clustering groups similar items together, like organizing different kinds of animals. 1. Examples include k-means and hierarchical clustering. 2. Association shows how things relate. 2. For example, people who buy bread often also buy butter. 3. Principal component analysis, PCA, simplifies data. 3. It keeps only the key details. 4. Autoencoders are unique computer models. 4. They learn to compress and restore data, similar to a smart zip file. 3. Reinforcement learning. Reinforcement learning is when a computer learns from its choices and their outcomes. It tries different actions, gets rewards for good choices, and learns from mistakes. This helps it figure out the best way to reach a goal, even in tricky situations. Some common reinforcement learning methods include: 1. Q-learning is a way for computers to learn the value of choices. 1. It does this over time and doesn't need a model of the environment. 2. Deep Q networks, DQN. This method mixes Q-learning and deep learning. 2. It helps computers learn from images and complex data. 3. Policy gradient methods. These methods improve decision-making directly. 3. They adjust strategies instead of guessing the best choice. 4. Monte Carlo tree search, MCTS, helps computers explore various options. 4. It picks the best option by testing various possibilities. 1. Linear regression. Linear regression models how dependent and independent variables relate. It does this by fitting a straight line, called the regression line, to the data. 2. Logistic regression. Logistic regression is used for classification problems where the outcome is binary, for example, 0 or 1, yes or no. It estimates the probability of an event occurring using a logit function. 3. Decision tree. A decision tree is a supervised learning tool. It works for both classification and regression tasks. It divides data into branches based on key features. 4. Support vector machine, SVM. SVM is a strong classification tool. It plots data points in an n-dimensional space. Here, n stands for the number of features. 5. Naive Bayes. Naive Bayes is a classification method that uses Bayes' theorem. It assumes that all features in a dataset are independent of each other. Naive Bayes may seem naive, but it works great with large datasets. 6. K-nearest neighbors, KNN. Algorithm KNN is a simple and powerful algorithm for classification and regression. It is mostly used for classification in data science. It stores all the data points. Then, it classifies new data points by the majority vote of their k-nearest neighbors. The distance function, for example, Euclidean distance, determines the similarity between points. Considerations before using KNN. Black tick mark. It can be very costly to compute, especially with large datasets. Black tick mark. Normalizing features is essential to avoid bias from variables with wider ranges. Black tick mark, pre-processing is needed for improved performance. 7. K-means clustering. K-means is an unsupervised learning algorithm used for clustering problems. It organizes data into K-unique clusters. Compression. 8. Random forest algorithm. A random forest is an ensemble of multiple decision trees. Each tree gives a classification. The final prediction comes from the majority vote of all trees. How random forest works. 1. A random sample of n cases is selected from the training set. For each tree, only a random subset of features, m out of m total features, is considered at each split. Advantages. 1. Reduces overfitting compared to individual decision trees. 2. Handles both classification and regression tasks. 9. Dimensionality reduction algorithms. Big data is everywhere now. So, finding important patterns and cutting out noise is key. Dimensionality reduction helps simplify datasets by selecting the most important features. 10. Boosting algorithms. Gradient boosting and